Welcome to Daily Papers, the podcast where we break down cutting-edge research into a conversation you can actually follow. Today, we're talking about a future that's coming faster than you think, a world where AI agents aren't just chatbots, but are running entire businesses for us online.
And it turns out, when you get a bunch of super smart AIs all trying to sell you stuff at the same time, things can get weird, really weird. We're looking at a paper from Princeton University called Agent Bazaar, enabling economic alignment in multi-agent marketplaces.
That's a mouthful. Let's start with economic alignment. What does that even mean? I've heard of AI alignment, which is about making sure AI is safe and doesn't harm humanity. Is this the same thing?
It's related, but more specific. Economic alignment is about making sure that when AIs participate in the economy, they don't accidentally break it. The goal is to have them contribute to a smooth, stable market, not one that's chaotic or full of fraud. An AI can be perfectly helpful and harmless to you individually, but its actions, when combined with thousands of other AIs, could be collectively catastrophic.
Okay, so how do you test for that? You can't just unleash a bunch of experimental AIs onto Amazon and see if the economy collapses.
Right, you definitely can't. So the researchers built a simulation, a virtual playground for AIs, which they call the Agent Bazaar. It's a digital laboratory where they can create different kinds of online marketplaces and see how AI agents behave. And they found two major ways things can go wrong.
Let's hear them. What's the first disaster scenario?
The first one is called the crash. Imagine a simple online market, like 5 different AI-run stores all selling the exact same product. They're all programs to maximize profit. One AI figures out it can get more customers by lowering its price by 1 cent.
And then another AI sees that and lowers its price by another cent to compete.
Exactly. But AIs do this instantly and relentlessly. They get into a recursive, undercutting price war. They keep dropping the price until it's below what it even costs to make the product. Every sale loses them money. Before you know it, all the AI-run stores go bankrupt and the market completely collapses.
That sounds a lot like the flash crash we've seen in stock markets, but for regular goods.
It's the same principle. Individually, each AI is making a rational decision to get the next sale, but collectively, it's a race to the bottom that destroys the entire system. That's what they call algorithmic instability.
Okay, that's one failure. You said there were two. What's the other one?
The second one is called the lemon market, and this one is all about deception. Picture a marketplace like eBay or Craigslist for used cars, but again, populated by AIs. Now, imagine one scammer creates a single deceptive AI.
Just one?
Just one. But this AI is clever. It creates dozens of different seller accounts, each with its own name, its own writing style, and its own fake reputation. This is called a Sybil attack, where one person pretends to be many different people.
And I'm guessing it's not selling great cars.
It's selling junk, lemons. The AI writes a fantastic, convincing description for a terrible car. A buyer AI might get tricked and buy it. When that seller account gets a few bad reviews, the scammer AI just shuts it down and activates a brand new, clean account. Trust in the market evaporates because you can't tell the good sellers from the fake ones.
So in these two scenarios, how did the big state-of-the-art AIs, the ones we hear about every day, actually perform?
They mostly failed. In the crash scenario, most of the big models engaged in those destructive price wars and went bankrupt. In the lemon market, they were easily tricked by the deceptive seller. And the fascinating thing the researchers found is that model size didn't matter. Being a bigger, supposedly smarter model didn't make you any better at this. Economic alignment is a totally different skill.
So if just using a better AI isn't the answer, what is? Did the researchers find a fix?
They tried 2 things. The first was a simple fix they called harnesses. This is basically just giving the AIs a specific set of instructions, a bit like a corporate policy. For the crash scenario, they created stabilizing firms. These AIs were told, your job is to hold a stable price above your costs. Do not get into a price war even if your competitors are.
And for the lemon market, I'm guessing they created some sort of detective AI.
You got it. They called them skeptical guardians. These buyer AIs were told to be skeptical. Check the seller's reputation, see if the price makes sense for the quality being advertised, and look for patterns. If it seems too good to be true, just pass and wait for a better deal.
And did these simple instructions work?
They helped. They definitely improved the outcomes. But the researchers found they were fragile. When the market conditions got really tough, like when there were a lot of aggressive competitors or a ton of scammers, these simple rules weren't enough, and the AIs would start to fail again.
So that brings us to the second, more robust solution, I assume.
Yes, the researchers decided to actively train an AI to be economically aligned. They took a medium-sized model and trained it using a technique called reinforcement learning. It's like training a dog with treats. They had it play in the agent bazaar over and over, and they rewarded it for actions that led to a stable market and punished it for actions that led to crashes or getting scammed.
And how did the custom-trained AI do?
It was a superstar. This relatively small, specially trained model outperformed all the giant general-purpose models. In the crash, it learned to act as a price anchor. It would hold a reasonable price, and its presence alone was enough to prevent the other AIs from starting a price war, stabilizing the entire market for everyone.
Wow, so it didn't just save itself, it helped the other AIs too. What about in the lemon market?
It became an expert scam detector. The trained skeptical guardian learned to spot the fake listings with over 90% accuracy, effectively starving the scammer AI of revenue and protecting the integrity of the market.
That's incredible. So the big takeaway here is that we can't just assume bigger AIs will be better at everything. Some skills, like being a responsible market participant, need to be taught specifically.
Precisely. And to measure this, the researchers proposed a single metric, the Economic Alignment Score, or EAS. It's like a final grade that combines four things: market stability, market integrity, consumer welfare, and profitability. It gives us a simple number to compare how well different AIs behave in an economic setting.
So this paper gives us not only a warning about what could go wrong, but also a toolkit, a simulation to test AIs, and a training method to fix them.
Exactly. It's a roadmap for how to build AIs that are not just smart, but are also good market citizens. It's about making sure that when we hand over the keys to our digital storefronts, they don't immediately drive the car off a cliff. And that seems like a pretty important thing to figure out.